to have you on Fascinating Frontiers, episode 67. It's May 10th, 2026. Here's your space and science briefing. A commercial spacecraft has completed final tests for NASA's first satellite rescue mission in a crowded orbital environment. Fresh modeling now ties Saturn's rings directly to debris from a shattered moon. The work links the ring's total mass and pure icy makeup to a single body called chrysalis that broke apart roughly 100 million years ago. That one catastrophic collision accounts for the ring's present structure far more cleanly than earlier ideas of slow erosion from many small objects. It also places the rings among the youngest major features we see in the solar system today. The result shifts our view of how quickly large-scale changes can still occur even in a mature planetary system. From one long-standing solar system mystery to another formation puzzle, we turn to galaxies that apparently never started spinning. Data from the James Webb Space Telescope and other instruments have uncovered a galaxy in the first few 100 million years after the Big Bang that shows no sign of rotation at all. Standard models expect early systems to settle quickly into orderly spinning disks fed by steady gas inflows. Instead, this object appears to have grown through repeated chaotic mergers and turbulent inflows that never produced net spin. The finding forces a closer look at how some massive cores could assemble without acquiring the angular momentum we see everywhere in later galaxies. You know what is fascinating about this? If you could shrink the observable universe to the size of a football field, these first galaxies would sit as faint specks within the first few meters from the goal line. They condense from turbulent clouds whose random motions never organized into rotation. Material fell inward along chaotic filaments and built dense cores through mergers, some reaching stellar masses like the Milky Way's bulge when the universe was less than 600 million years old. We can map their light and velocities, yet the reason certain pockets avoided net angular momentum remains unexplained. The open question is whether these objects later gained spin or represent an entirely separate channel that simply faded. While some early galaxies skipped the spin cycle, others were busy forging complex carbon molecules we still find today. 15 years after the first detection of buckyball molecules in space, new spectra and images have now pinpointed where they form. The James Webb Space Telescope shows these soccer ball-shaped carbon cages, condensing inside dense shells around aging stars. Carbon-rich gas in those shells supplies the temperatures and radiation that let the molecules assemble. The discovery strengthens the connection between the late stages of stellar evolution and the organic building blocks that later end up in planets. What remains unclear is whether the same regions also produce larger carbon compounds that could feed prebiotic chemistry elsewhere. From molecules condensing in stellar nurseries, we shift to hardware that will soon operate in Earth orbit. A commercial vehicle has now passed its final ground trials ahead of NASA's first mission to capture and relocate defunct satellites. Success would demonstrate a repeatable approach for managing crowded orbital zones that are becoming increasingly hazardous. The effort also signals a broader move toward commercial companies taking on servicing tasks that once belonged only to government programs. While one commercial vehicle prepares to tidy Earth orbit, another Canadian-led system is advancing for lunar operations. MDA continues building the hardware for a Canadarm3-style robotic arm, while the Canadian Space Agency reviews the next project phase. The arm is designed to handle maintenance and logistics tasks on the planned lunar outpost. It extends Canada's long record of contributing proven robotics to international missions. From robotic arms reaching for the moon, we look skyward for planets circling two suns at once. Repeated dimming patterns in the combined light of binary stars have revealed several new planet candidates orbiting both members of the pair. These systems echo the fictional Tatooine, yet were found through careful timing of transits rather than direct imaging. Each detection adds to the census of worlds that formed and survived in dynamically complex environments. From planets in unusual orbits, we return to our own skies and a comet brightening for backyard telescopes. Comet Tempel 2 is now glowing at roughly magnitude 15 as it crosses the constellation Aquila. Observers with larger telescopes can follow it as it rises later each night and grows steadily brighter through the season. It provides a steady, practical target for amateur astronomers watching from dark sites. While observers track a comet, NASA is actively looking for the next generation of engineers to keep future missions flying. The agency and the Office of Personnel Management have opened the NASA Force recruitment drive aimed at technologists and engineers. The campaign targets critical roles that support ongoing exploration programs across the agency. With recruitment underway, we close by noting how much formation history still hides in plain sight. Next time, keep an eye on fresh results from the James Webb Space Telescope that could clarify how those non-rotating early galaxies fit into the larger story of cosmic structure. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.